To begin with, we discover the 5 tests of resistor to find and to discover its resistance. 4 colored band resistors can be discovered within the web. With the assistance of color-coded resistor direct, we are able to discover to decide the esteem of the color groups that we utilize it to be a rule to discover the esteem of our resistor. We recognize how much is the resistance and how to study the color within the band code. All the assembled information will be recorded and will be encoded within the table that's found within the layout given. The information will be, at that point, examined and analyzed.
For our table, we are going to have 5 trials of resistor, the color bands which consist of the first band, second band, third band or the multiplier, and the fourth band. We also have the value of the fixed resistor in ohm. We have here the first diagram. For the first band, we have green. For the second band, we have red. For the third band, we have red. And for the fourth band, we have gold. For our second trial, we have yellow for the first band, violet for the second band, brown for the third band, and gray for the fourth band. For our third trial, we have brown for the first band, green for the second band, red for the third band, and violet for the fourth band. For our fourth trial, we have red for the first band, black for the second band, red for the third band, and gray for the fourth band. For our last trial, we have brown for the first band, blue for the second band, red for the third band, and gold for the fourth band.
We have here the computations for the value of the fixed resistor in ohm. In this table shows the color bands that we choose to get the value. And in order for us to get the value of the fixed resistors, we need to compute. And the equation for the computation are first bond and second bond times the multiplier bond equals the answer. And then we should put the tolerance bond with it. So let's continue to the computation. So we have here the resistor number 1. The first bond of the resistor 1 is green with the value of 5. We'll put the value of the first bond here, which is 5, plus the value of the second bond, which is red, and the value of red is 2. We'll put here 2 times the multiplier bond, which is color red also, and we have the value 100. So 100, so 52 times 100, so equals 5,200. So 5,200 is the value of the resistor. Or we can simply write resistor equals 5.2 k ohms with a positive negative tolerance. And our fourth bond, which is the tolerance bond, is good. That has a value of 5%. So we have positive, negative 5% tolerance. So the answer for the resistor 1, the value is 5.2K ohms with a positive, negative 5% tolerance. Next, we will compute the value of fixed resistor in resistor number 2. And the first bond in resistor number 2 is yellow with a value of 4. So we will put here 4 plus the second bond, which is the violet, that has a value of 7. So we will put 7, multiply by the multiplier, which is color brown, that has a value of 10. 10 equals 470. Or we have resistor equals 470 ohms with a tolerance bond, which is the gray, that has a value of 0.05. So 0.05 tolerance. So the value of fixed resistor in resistor number 2 is 470 ohms with a positive, negative 0.5% tolerance. So we will continue to the resistor number 3. So the first bond for the resistor number 3 is color brown, that has a value of 1, number 1. And the second bond, we have green, that has a value of 5, multiplied by the multiplier, which is the color red, that has a value of 100. 100 equals 1,500. Or we can write it as resistor equals 1.5 K ohms with a positive and negative tolerance. And the tolerance bond for resistor 3 is we have color violet, that has value of 0.10 or 0.10. 0.10% tolerance. And we will continue in the resistor number 4. And the first bond for the resistor number 4 is red, that has a value of 2. And second bond is black, that has a value of 0. Times the multiplier bond, which is the color red also, that has a value of 100. So 100. So we have 20 times 100 is 2,000. Or we can write it as 2 K ohms with a positive and negative tolerance. And the color for the tolerance bond is we have the gray, and gray has a value of 0.05%. 0.05% tolerance. And for the last one, we have the resistor number 5. Resistor number 5 has first bond has the color brown, which has the value number 1. So number 1 plus the second bond, And the second bond, which is blue, has the value number 6, so 16, times the multiplier bond, which is the color red, that has the value of 100. So 16 times 100 is 1,600. Or we can write this as 1.6K ohms with a positive and negative tolerance bond, positive, negative, and the tolerance bond for resistor number 5 is gold, that has a value of 5%. So we have positive, negative, 5% tolerance bond. So we have here the final table, the final value of the fixed resistor. So resistor 1 has the value of 5.2K ohms, positive, negative 5%. Resistor 2 has the value of 470 ohms, positive, negative 0.05%. Resistor 3 has the value of 1.5K ohms, positive, negative 0.10%. Resistor 4 has 2K ohms, positive, negative 0.05%. And lastly, we have resistor number 5 that has a value of 1.6K ohms, positive, negative 5%.
We observe that each resistor includes four color bands. The first and second bands represents the first and second significant digit of the ohm value. The third band is the multiplier, and the fourth band indicates the tolerance of the resistor. The resistor color bands are combined together to indicate the value of the resistance resistor value. The value of the fixed resistor depends on the first, second, and third bands. As we multiply the value of the first and second band to the third band as multiplier, we get the fixed value of the resistor, and the results that the multiplier affects the value of the fixed resistor, whether the value is high or low. Analysis. Resistance is the property that determines the amount of current flow through a particular material. It is a measurement based on the difficulty to pass the current through a wire or component. Resistance is based on resistivity. Different combination of the color bands in the resistor is the value of the fixed resistor. It also differs from each resistor because each color has different value given in the resistor color code chart. The value of the fixed resistor in ohms depends on how high or low the value of the multiplier. The greater resistivity, the larger field needed to produce a given current density. The lower resistivity, the larger the current density produced. If the value of the multiplier is higher, the value of the fixed resistor is also high. On the other hand, if the value of the multiplier is low, basically the value of the fixed resistor is also lower. Resistors are the most commonly used components in electronic circuits and devices. The main purpose of a resistor is to maintain specified values of the voltage and the current in an electric circuit. A resistor works on the principle of Ohm's law. This law states that the voltage across the terminals of a resistor is directly proportional to the current flowing through it. Ohm's law is a formula used to calculate the relationship between voltage, current, and resistance in an electrical circuit. Fixed resistors are resistors with specific values. This type of resistors has a defined resistance and are not adjustable. The characteristic of a fixed resistor are its nominal resistance value and its maximum dissipation. Resistor color coding uses color bands to identify resistor's resistive value and its tolerance percentage with the size of the resistor indicating its wattage rating. The resistance values are printed on the body of a resistor as number or letters if the body of the resistor is big enough like the large power resistors. But if the power resistors are small, Then the specification are shown in a different way. Small resistors use color painted bands to indicate their both resistive value and the tolerance, with the physical size of the resistor indicating its wattage rating. The resistor color code markings are read from one band at a time, starting from left to right. Each color corresponds with different values, and the values are also differ according to where the color band is located. The value found by matching the color with its associated number in the digit column of the color code chart. The first two color bands indicate the significant figures, while the third band shows where the significant figures must be multiplied, and the last color band represents the tolerance in percentage.
The aim of this laboratory experiment is to determine the value of resistance of a fixed resistor using the color coding technique. The results of the experiment show that the experiment's objective was achieved. When only the positive tolerance is taken into account, we can infer that all bands have positive effect on the resistance value based on the data given in this experiment. The value of the fixed resistor is determined by the color of each band and its equal value. The third band of a 4-band resistor has a significant impact on the resistor's resistance value. The first, second, and fourth bands would then take the stage.